Hello everyone. Today we will study Unit 2, which is presentation of data. So till now you have studied how to collect the data, what are the challenges involved in data collection, and what are the different types of data and methods of editing the data and so on. Okay, so now once you have obtained the data, you have edited the data. Now in this unit, we will talk about the data presentation or how you have to present the data. Okay, so let us start. So the objectives of this unit is you will understand what is the basic need, why it is needed to present the data. Okay, the first question that will come, or first thought that will come to your mind is that the data needs to be presented so that it can be easily readable or easily understandable. Okay, if it is not presented in a proper manner, then you will not be able to understand the data. Okay, so we'll study how to present the data, and then with that we'll study classification of data. That is how to classify the data into certain similar groups. Okay, so that the objects within the group are similar to each other. How to classify the data. Classification basically makes it easy to understand the data. Okay, and once the data is classified properly, it can be presented also in a good way. And then third is we'll also understand and study how to construct a frequency distribution of both discrete data as well as continuous data. And then we'll also present frequency distribution in the form of a bar diagram, histogram, frequency polygon, and ogives. So we'll study all these things, and we'll cover all these units or all these topics in this unit. Okay. So coming to the introduction. So what is the need for presenting the data? As I told you. So if suppose if some guests arrive in your house and the things are not presented properly, then they may not like it. Okay, so how you're presenting something is very important. Okay, so data, the same thing applies to data. Okay, now you have collected the data, but if you are not able to present it properly, you yourself will not understand what the data is all about. Okay, so you will not have the feeling that how to start. No, okay, now I have the data. Now what should I do with this data? Okay, you will not be able to understand. So if that data is arranged in a very tabular form, in the form of tables or in the form of charts, as you can see, then it is very easy to understand. So in nowadays, you can see in the newspapers also, magazines, news, each and every place you will see either a table or a chart. Because that with that tabular or that with that presentation of data, not only you can understand it, but you can present it to other person as well. Okay, you can make the other person understand what the data is saying or what the data is all about. So presentation of data, it depends on a great extent on which how it is arranged, how it is displayed, and how it is summarized. So we learn all these things, that how to arrange the data, how to display and summarize the data in this unit. Okay, so as I told you, the presentation of the data can be in the form of either a tabular form, that is in the form of tables, or in the form of charts. Okay, before creating tables, it is necessary to classify the data. Classification is very important term in, you can say, in the data management, because without classifying the data, it would be very difficult to understand the data. Okay, so the data may be classified in the form of intervals or groups. Okay, so within those groups, the objects are similar, and the objects in different groups are different from each other. So if you classify and present the data properly, then the further steps will be very easy. Okay, you'll be able to analyze the data, you'll be able to interpret the data, and once you are able to interpret the data properly, you'll be able to convey, or you will be able to just make all your results come into practice. Okay, so once you understand and interpret the data, you can start including them in your decision making process. So presenting the data is a very important aspect. Okay, so let us start with classification of data. Okay, so what do you mean by classification? So classification is basically segregating the data. Okay, classification, the basic means of classification is segregating. Okay, segregating the data. Okay, so after the data has been systematically collected and edited, so the first steps which comes for the presentation of data is classification. Okay, so what do you do in classification? In classification, basically you arrange the points of data according to their similarities or dissimilarities. Okay, so like the group of data points which are similar are kept in one group, the other similar group of data points are kept in another group, and so on. So this is classification of data. So like for example, if you see an example of mail in a post office, so how do they segregate the data there, the letters there? They segregate them according to the postal address. Okay, so for different postal address, they have different sets of letters. So basically, classification deals with segregating the data. Now, what are the objectives of classification? So first objective is to condense the data, because all the data points all the letters are just lying there, and so it's very difficult to understand which letter belongs to which place. So basically, you are segregating the data, you keeping the data neatly so that you can notice the salient features of the data. Okay, then once the data has been segregated, it will be easier to compare between the attributes of the variables. So you can compare between different groups in terms of the variables. So comparison becomes easier. Third is, once you can compare also, and you can present the data in the tabular form also. Okay, so once you have segregated the data, you can do comparison and prepare the data in tabular form. And once the data has been prepared in tabular form, it will automatically highlight, or you can also study the significant features of the data at a glance. So at a glance, you'll be able to understand, you'll get some idea of what the type of data is and what the data is trying to say. Okay, now let us study types of classification. So basically, there are 4 types of classification. First is geographical, which is according to area or region. Second is chronological. Chronological means occurrence of an event with respect to time. So there is a ordering with respect to time here. Okay, qualitative means according to some attributes or properties, and quantitative means according to magnitudes or numbers. Okay, so let us study each of these in detail. Okay, so coming to the geographical classification. So what happens in geographical classification here? As I told you, the data is classified according to area or region. For example, if you want to consider, this is an example, if you want to consider the production of wheat, okay, that is state-wise. Okay, so this will be called a geographical classification. Okay, and the listing of individual entries are generally done in an alphabetical order or according to size, to emphasize the importance of particular area or region. So if our area or region has more size, then it means it is more important. So when you're classifying keeping geography in mind, then that is called a geographical classification. Okay, or if you're classifying something according to states, the votes according to states, that is geographical. Then chronological. What do you mean by chronological? So as I told you, with that, it is with respect to the time of occurrence. Okay, so which happened first, which happened later. So this is the example of chronological classification. Okay, for example, you have a data of year and you have the data of sales. Okay, so suppose your sales in the year 1982 to 83 was 175. Okay, sales in the year 1983 to 84, that is 220. Then in the increasing order, as you can see, then 1984 to 85, it was 350 and so on. So this is example of chronological classification. Okay, this is some ordering according to time. Now, what is qualitative? Qualitative means according to some attributes or some categories. Okay, so you are sorting the data according to some categories. Okay, so when the data is classified according to some attributes which are not capable of measurement, so you can't here measure anything. So you have some categories in which you are classifying the data. For example, there may be two categories. One is possessing some quality and one is not possessing some quality. For example, one category can be employed, another category can be unemployed. So such type of classification is called qualitative classification. Or education can be classified into three classes, for example, primary, middle, and higher education, and so on. So this is qualitative classification. Then coming to quantitative classification. In quantitative classification, what happens? The data is classified according to some characteristics that can be measured. Okay, some characteristics that can be measured. For example, the employees of the company, if there is a certain company, then the employees can be classified according to their monthly salaries. So monthly salaries you can measure. So they can be classified according to their monthly salaries. Okay. So since quantitative data is characterized by different numerical values, the data will represent the values of the variable. Okay, so these are the quantitative classification in which there is a set, or just suppose weight or height you are measuring and you are noting down, that is quantitative classification. Okay, now before coming to discrete and continuous frequency distribution, we should understand what does the term discrete means and what does the term continuous means. Okay, so by discrete you refer to mainly quantitative data. Okay, and so basically these are the integer or numerical values of the variable. So it will be integer or numerical values. Okay, and for example, the number of employees in an organization or the number of machines in a factory are example of distinct data. Now, what is continuous data? So continuous data can take integer values also, and it can take fractional values also. Okay, so for example, the data related, as I told you, relating to weight, distance, volume. So these are measured on a continuous scale. So these are the data which is known as continuous. This type of data is known as continuous data. Okay, and the quantitative classification. For this quantitative classification, it becomes the basis for the frequency distribution. So we will study frequency distribution. So for this frequency distribution, the quantitative classification becomes the basis. Okay, so let us study what is discrete and continuous frequency distribution. So when the data is arranged in group or categories, okay, according to some conveniently established division of the range of observation, such an arrangement in tabular form is called frequency distribution. So what do you do in frequency distribution? Basically, you represent the raw data. Okay, so the raw data here is represented by some distinct groups. Okay, and these distinct groups are known as classes. So we will see an example of classes. So you arrange the raw data in some groups, that is classification, and each group is called a class. Okay, and the number of observations that fall into each class is known as frequency. So there is a raw data, unarranged data. You are classifying it to certain groups. Each group is called class, and the number of observations which fall in each group or each class is called as frequency. Okay, so there are two parts, classes and frequencies. For example, let us see this example. Okay, so this is a discrete frequency distribution and this is a continuous frequency distribution. Okay, so when the data is represented by a continuous variable, it is called continuous data, as I told you. And when a data is represented by discrete variable, it's called discrete data. So that is clear. Now, what is discrete? So here are the discrete data values here in this, if you see 110, 120, 130, 140 and all. So this is discrete data. So and for each number of employees, you're getting the number of companies. Okay, so for each data, this is corresponding frequencies. So for example, 25 companies, they account for 110 employees. 35 companies, they account for 120 employees. So such type of data is called a discrete frequency distribution. Okay, and see here, it is a continuous frequency distribution. So here you can see there are certain categories. So continuous data is distributed. So age can be 20 years, it can be 21.5 years, or it can be 22.5 years. So this is continuous. So for each class, you are having a frequency. So this is a continuous frequency distribution. Here integer values are allowed. Here fractional values are allowed. Okay, like 25.1, 25.2. Here fractional values are not allowed. So this is a continuous frequency distribution. So the two types of distributions are there: discrete frequency distribution and continuous frequency distribution. Okay, so then after this, we'll study how to construct a discrete frequency distribution. Okay, so I'll illustrate this by an example. So suppose this is a data. So to illustrate the construction of discrete frequency distribution, you have to consider a sample study in which 15 families were surveyed to find the number of children per family. So this is the data of 50 families, and for each family, the number of children per family is given. Okay, so this is the raw data which is given. Now what you have to do, you have to construct a frequency distribution, discrete frequency distribution for this data. Okay, so how will we do it? So suppose you will make 2 columns, okay, or basically 3 columns. So first will be the number of children, okay. So first will be the number of children, okay, and then number of families. Okay, number of families, and then third will be the frequency. Okay, so number of children, as you can see, the lowest is 0 and the maximum is 6 children. Okay, so you can write here numbers are 0, 1, 2, 3, 4, 5, 6. So as you can see, this is discrete data. Okay, fractional values are not allowed. So 1.1, 2.1, 2.3, like this. This is not possible. Okay. So now number of families which have 0 children. Okay. So you have to count. So it will be 1, 2, and 3. So number of families 3 and 4. So number of families which have 0 children or which don't have children are 4. Okay, so this is 4. Now you have to represent the number of families by the method of tally marks. Okay, so tally marks, what you do. So suppose it is 4. So you will put 1, 2, 3, 4 straight lines. Okay, now let us see for 5. Okay, similarly you have to do for 1, 2, 3, and 4. Okay. Now let us see for 1. Okay, after 0, let us see for 1. How many families have 1 children? So let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 families have 1 children. Now how will you represent this by tally marks? Okay, so what you will do? 1, 2, 3, 4. 4 you will do. 5th you will be putting it as a slanting line. So this is the rule of tally marks. So 5 you have to represent like 1, 2, 3, 4, and 5th line will be a slanting line. Okay, so after this is 5 is done. Now 4 more are left. So 1, 2, 3, 4. Okay, now let us see for 3 children. Okay, let us see for 3 children. How many families have 3 children? So like 1, this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 families have 3 children. Okay, so how will you represent by tally marks? Again, the process is same. So 1, 2, 3, 4, and 5. So this will represent 5. Again, 1, 2, 3, 4, and 5. 5 plus 5 is 10. And 2 more, so 12. So this is how you represent the distribution, a discrete frequency distribution with the help of tally marks. Okay, so I hope this is clear for all of you. So this is what I was talking about. Okay, so same thing we have done. So as you can see, the number of frequencies corresponding to number of children, that is 0, is 4, corresponding to 1, that is 9, and so on, and the total is 50. So the total of the frequency is 50. Okay. Now, let us study how to construct a continuous frequency distribution. Okay, so for constructing the frequency distribution for continuous data, it is necessary that we should understand some important terms which are frequently used. Okay, so without these terms, it will be difficult to understand what is frequency distribution. Okay, so first comes the class limits. Okay, so this first is these are the class limits. Okay, class interval, class frequency, class midpoint, type of class interval, like that is exclusive and inclusive method, and the open end. Okay, so we will see each of this in detail. So coming to the class limits. So what do you mean by class limits? So class limits basically they denote the lowest and highest value that can be included in a class. Okay, so these are the lowest value. Okay, and this is the highest value that can be included in a class. For example, if the class is 60 to 69, then the lower limit will be 60 and the upper limit will be 69. Okay, so this means that we can say that there is no value in that class. So there will be no value which is less than 60 or which is more than 69. Okay, so these define the class limits. Now coming to the class intervals. What do you mean by class intervals? So class interval basically represents the width of a class. Okay, so class interval represents the width of a class. And how to determine width? So you can determine width by taking the difference between the upper limit and the lower limit. So how you can determine? So it will be the difference between upper limit and lower limit. Okay, so for in this case like 60 to 69, what will be the width? It will be 69 minus 60, that is 9. So this is how you determine the class interval. What is class frequency? So class frequency, as we discussed, the number of observations. Okay, so the number of observations which fall in a particular class. Okay, so that is called as class frequency or simply frequency. Okay, and what is the total frequency? Total frequency, as we saw, this is the sum of all the frequencies. This is the total frequency. What is class midpoint? Okay, so class midpoint of a class is defined as the sum of the class limit divided by 2. Okay, so suppose the class is 10 to 20. So what will be your class midpoint? It will be 10 plus 20 divided by 2, that is 30 divided by 2, that is 50. Okay, so this will be a class midpoint. Now there are two types of class interval, exclusive class interval and inclusive class interval, or exclusive method and inclusive method of class interval and open end. So first we will study what are exclusive class intervals. What is exclusive class intervals or what is exclusive method? So in this, the class intervals are so arranged that the upper limit of one class is the lower limit of the next class. So here, let's see this example. This is the upper limit of this class, which is the lower limit of the next class. Similarly, this upper limit is the lower limit of the next class. So this is what is exclusive method. Okay. For example, here, in this example, there are 20 firms whose sales are between 20,000, okay, whose sales are between 20,000 and 24,999, 24,999 rupees. Okay, and a firm with sales of exactly 25,000 that will lie in this class, 25 to 30. Okay, so 25 will be not included in this class, it will be included in this class. Okay, so in the exclusive method, what we say that we always presume that the upper limit is excluded. Okay, so in this exclusive method, upper limit is excluded. This is exclusive method. Okay, now coming to the inclusive method. So what happens in inclusive method? So in inclusive method, the upper limit of one class, so what happens? The upper limit of one class is included in the class itself. Okay, so for example, if we see the following, so it is like 24.999. So it is in the sales is in thousand. So 20 means 20,000 and 24.999. If you multiply it by 1,000, you will get 24,999. So it will be 24,999 rupees. Okay, so if you multiply it by 1,000, 24.999, you will get 24,999. So, this is the example which will illustrate this inclusive method. So, in this example, there are 20 firms, okay, whose sales are between 20,000 and 24,999 rupees. Okay, and a firm whose sales is exactly 25,000 will fall in this class. Okay, so this will fall in the next class. So what happens in the inclusive method? It is presumed that the upper limit is included in the class. Therefore, it is called inclusive class. Okay, so actually both the inclusive and the exclusive method, they give the same frequencies, although the class intervals are a bit different. Okay, now let us study what are open-end distributions or open-end classes. So open-end classes are the one in which the lower limit of the first class, okay, so the lower limit of the very first class and the upper limit of the last class is not given. Okay, so if you see here, this is the first class in which the lower limit is not given. It's just little less than 1,000. So the lower limit is not given. Here, the upper limit of this class is not given. It's just written at 25,000 and above. So the upper limit is not given. So such type of classes are called open-end classes. Okay, so what happens? So this is a correction factor. So what is where is the correction factor used? So basically, it is used to ensure continuity. Okay, so if you want to ensure continuity and you want to get the correct class intervals, you should basically use exclusive method. Okay, if the class intervals are not exclusive, then you have to convert them into exclusive classes. Okay, so suppose a class is inclusive, then what you have to do? You have to make an adjustment so that that inclusive class is converted into exclusive class. So this is the correction factor. This is the adjustment which is done. So this correction factor is given as lower limit of second class minus upper limit of the first class divided by 2. Okay, so let us see here how this is done. So here, if you see the inclusive method, so in that case, when we were discussing the inclusive method, so if you see here, so here if you see the lower limit is 20,000 and the upper limit is 24.999, or if you multiply it by 1,000, it will be 24,999 rupees. Okay, now you want to determine the correction factor. So how you will determine the correction factor? So correction factor is lower limit of the second class. Lower limit of the second class is 25. So it will be 25 minus upper limit of the first class. Upper limit of the first class is 24.999 here. Okay, so and you will divide it by 2. So when you will solve it, you will get 0.0005. Okay, so what you have to do, you have to subtract this value from all the lower limit and add these values on all the upper limit. Okay, so here if you see, if you subtract this correction factor 0.0005 from 20, you will get 19.995. Okay, and when you will add this to this 24.999, you will get 24.995. Okay, so similarly, you have to subtract this adjustment factor from the lower limit and add it to upper limit. So what you will get here is table looking like this. Okay, so from each lower limit, you are subtracting 0.0005 and you are adding 0.0005 to the upper limit. So this is how you will get the inclusive in this case, so this is how your inclusive class will be converted to exclusive class. Okay, so this I have shown here. So same thing I have done, 24 minus 35 minus 24 here, 25 minus 24.999, which is divided by 2, and that is 0.005. Yeah. Now there are some guidelines for choosing the number of classes. Okay, first of all, the number of classes should not be either too large or too small. Okay, for preferably the number of classes should be between 5 to 15. Okay, so but it is no hard and fast rule. So if the number of observation is smaller, the number of classes formed should be towards the lower side of this limit. And when the number of observations are larger, the number of classes should be towards upper side of this limit. So basically, there's no hard and fast rule. The number of classes can be 5 to 15. If the observations are very small, then the number of classes should be lower side of that limit. And number of if the observations are large, then the number of classes should be towards the larger side of the limit. And then the second is if possible, the width of the interval should be numerically simple. Okay, so it should be values like 5. It should be values like 10, 25, etc. And you should avoid values like 3, 7, 19. Okay, so it should be simple. Third, it is desirable to have classes of equal width. So classes should be of equal width. However, what happens when there are distributions which have a wide gap between the minimum and the maximum values, then what happens? Classes with unequal class intervals can be formed like income distribution. So when there is a large wide gap between minimum and maximum values, you can form classes with unequal width, but generally it is desirable to have classes of equal width only. Okay. Then fourth is the starting point of each class should begin with like 0, 5, 10 or multiples. Okay. For example, if the minimum value in a data or distribution is 3, okay, and we are taking the interval of suppose 10, then we should form intervals like 0 to 10, but we should not do it like 3 to 13. Okay, we should start with like 0 ideally, so it should be 0 to 10 to 10 to 20 and so on. Okay, and then the fifth point is the class interval should be determined after taking into consideration the minimum and the maximum value and the number of classes to be formed. So this minimum value, the maximum value, and the number of classes to be formed, this all should be considered while determining the class interval. For example, let us see. If the income of 20 employees in the company, okay, there are 20 employees whose income varies between 1100 rupees and 5900 rupees. And suppose you want to form 5 classes. Okay, so the class interval can be like upper value minus lower value. You can divide by and the class interval, suppose you want to be 1000. So class interval, if you want to be 1000, then you can divide by 1000. So it will be 4.8. So approximately the class interval can be 5. Or then, sorry, the number of classes would be 5. Okay. So here what you are doing, let me explain this again. So first of all, when you are forming when you want a class interval, you should take into consideration the minimum values and the maximum values. So if suppose there are 20 employees in the company whose income is varying between 1100 and 5900, and suppose you want to form 5 classes. Okay, so you should get 5 here or some near multiple of 5. So what you will do? So in that case, if you want to get 5 here, so first you will subtract here 5900 minus 1100. Okay, so 5900 minus 1100, it will be 4800. Okay, so but you want to get some multiple of 5. So for what you will divide some value around 5 if you want. So you can divide it by 1000. So you will get it as 4.8. So 4.8 or 5. So you can take the class interval as 1000. Okay, so this is a crude way or a rough way of determining the class interval. So want to determine the class interval, just take the minimum and the maximum value, and suppose you want 5 intervals, so you take you should get a value around 5, somewhere around 5. So you should have to see by what number you have to divide so that you can get a value somewhere around 5. So if you here, in case if you divide by 1000, you will get somewhere around 5. So the class interval can be 1000. Okay, so these are some of the guidelines which should be kept in mind for choosing the classes. Okay, and you should be very well familiar with different different definitions, such as what are classes, what is frequency, what is class interval, what is class width. All you should remember. Okay, and these are the some of the guidelines for choosing the classes. So let us discuss what is meant by cumulative frequency and what is meant by relative frequency. So cumulative frequencies, as the name suggests, it cumulates the frequencies. Cumulates means it totals the frequencies. Okay, so cumulative frequency is basically, it cumulates the frequencies starting at either the lowest or the highest value. Okay, so it will start either at the lowest value or the highest value. So the cumulative frequency of a given class interval, it represents the total of all previous class frequencies. So it will represent the total of all previous class frequencies, okay, including the class against which the frequency is written. So you will see an example in which it will be clear how to calculate the cumulative frequency. So we'll do it here itself so that it becomes easier for you to understand. Okay, so we'll introduce a new column here. Okay, so this will be your cumulative frequency. Okay, now let us see how to calculate the cumulative frequency. So first, let us start for the first class, that is 5. So here the cumulative frequency will be same as 5. Then what will be the cumulative frequency here? It will be sum of the previous class frequencies, including the class against which the frequency is written. So it will be 14 plus 5, that is 19. The cumulative frequency for this class will be 23 plus 14 plus 5. Okay, so it will be how much? It will be like 742. Okay. Similarly, the frequency corresponding to this class will be 50 plus 23 plus 14 plus 5. So how much it will become? 92. Similarly, you will write for all. So here it will be 144. That okay. Here against this class it will be 169. Okay, then you will get 191. Then it will be 198, and then this will be, last one will be sum of all the frequencies, that will come as 200. So this is how you write the frequency, the cumulative frequency. So this is the total cumulative frequency. Fine. So this is how it is being done here, the same method I've told you. Now let us see what are relative frequencies. Okay, so what happens that very often the frequencies in a frequency distribution, why they are converted to relative frequencies? Because to show the percentage for each class. So main function of relative frequency is to show the percentage of each class. Okay, how do you calculate the percentage of each class? So in that case, frequency of each class is divided by the total number of observations or total frequency. Okay, so how this percentage is calculated? That is frequency of each class divided by the total frequency. Okay, and you multiply it by 100. So for this example, let us see how this is calculated. So this was your data. These are the number of employees. Okay, so here, how do you calculate? So this is here 200. So how will you calculate the relative frequency here? So for this, it will be 5 divided by 200. Okay, that will be 0.025. Okay, then here it will be this 14. Okay, this 14 divided by 200. And this one will be 23 divided by 200. Similarly, this will be 50 divided by 200. and so on. Okay, so these are the relative frequencies. Once you multiply this relative frequency by 100, you'll get the percentage. So 0.025, if you multiply it by 100, you'll get 2.5%. Similarly, 0.070, if you multiply by 100, you will get as 7. So this is what relative frequencies are. Okay, so there are two main advantages of relative frequencies. The first is relative frequencies, they facilitate the comparison. Okay, so they facilitate the comparison of two or more than two sets of data. You can easily compare more than two sets of data, and relative frequencies, they constitute the basis of understanding the probability. So the concept of probability is itself based on the relative frequency concept. Okay, so when you study, or if you might have studied probability, you will come across the concept of relative frequencies. Okay, so now let us understand charting of data. Okay, so what do you mean by charting of data? Charting of data means that charts of frequency distribution which cover both diagrams and graphs. So charting of data means charts of frequency distribution. Okay, charts of frequency distribution. Okay, what is the advantages? The advantage is that they enable a very quick interpretation of data. Okay, so they enable a very quick interpretation of data. Okay, so there are following four methods which are used for charting the data. The first is the bar diagram, the second is the histogram, the third is the frequency polygon, and fourth is the Ogive or cumulative frequency curve. Okay, so now first let us see the bar diagram. So what is a bar diagram? So a bar diagram, these are the most popular ones. Okay, so if you might have seen many bar diagrams in newspapers, journals, exhibition, even on television, on news, etc. You must have seen. Okay, so for example of this bar diagram may be like it shows the per capita income. Okay, so bar diagram shows per capita income, or they may show sales of a company, or they may show profit of the company over the years, and so on. Okay, so bar, what is a bar? A bar is basically a thick line whose width is shown to attract the viewer. So this is a thick line sort of, and it may be a vertical bar diagram also. These are the vertical bar diagrams, and it can be horizontal also. Okay, like this, depending upon the requirement. So let us see how to draw a bar diagram. Okay, so for this, see, if you are seeing here, if you see in this figure, so this is the population figures in millions. Okay, so this is the population in millions of India. This is the population. Okay, so now if you see this bar diagram, so you have to take the years on the x-axis. So you have taken on the x-axis, you have taken the years. Okay, and on y-axis, what you have taken? On y-axis, you have taken the population. Okay, as you can see from the diagram, the gap between one bar and the other bar is kept equal. Okay, so the gap between, see, this gap between the bars is kept equal. Okay, and the width of the bar is also same. The width, this width of the bar is also same. The only difference which you are seeing is in the length of the bar. So here in 1931, the population was 278.98 million. It is coming somewhere here. Okay. In 1941, the population was 318.66 million, and so on. For each, you can note the reading. So this is how a bar diagram is drawn. Okay, now the next comes the histogram. So histogram is one of the most commonly used and easily understood method for graphical presentation of frequency distribution. So this also is used for graphical presentation of frequency distribution. What is a histogram? It is a series of rectangles. Okay, so histogram is basically a series of rectangles, okay, that have areas which that are in the same proportion as the frequency. So the area of the histogram is in same proportion as the frequency. Okay, so let us see an example of this histogram. So this is daily sales in thousands. Okay, and then this is the daily sales in thousand. These are the number of companies. Okay, now you have to draw a histogram. So if we go ahead and draw a histogram here, so you see here, so here 10 to 20, 20 to 30, 30 to 40, 40 to 50, and so on. These are the intervals, as you can see here. Okay, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and so on. And for each corresponding histogram, there is a reading. Okay, so if you see here, for 10 to 15, 10 to 20, it is 15. Okay, so here if you see, it is marked, this is 15. Okay, then for 20 to 30, what it is? 22. So we'll go ahead and mark this in the graph. So 20 to 30 is 22. Similarly, you can do for others. Okay, so this is how a histogram is drawn. Okay, now so here the area of the histogram, it represents the total frequency as distributed. So for the whole area of the histogram will represent the total frequencies. So but sometimes what happens that the width of the class intervals are not equal. Okay, so in this case, the width of the, as you can see, the width of the class interval were equal. Okay, what happens when the width of the class interval is not equal? So if you see here, here the width of the class interval is not equal. So what is the width here? 1500 minus 1000. The width of the class interval is 500. What is the width of the class interval here? Again, it is 500 for this. Here is also 500. But what is the width of class interval here? It is 1000. Okay, that is 3500 minus 2500. So this is an unequal class interval width. Okay, so we have to find out the adjusted frequency of each class. Okay, how do we find the adjusted frequency of each class? We have to take the class with the lowest class interval as a basis of adjustment. So we have to take the class with the lowest class interval. Okay, so we have to take the class with the lowest class interval. Okay, so here, for example, in the class, so what is the lowest class interval here? It is 500. Okay, and the next lowest class is 1000. Okay, so this is 2500 minus 3500, which is equals to 1000. Okay, and here what is the class interval? It is 1500. Here it is 2000. Here it is 1000. So the lowest width is 500 and the next lowest is 1000. Okay, so how will you do it? So you have to create classes of equal width. Okay, so this is here 5. This is already 500 here. Okay, here it is also 500. Here it is also 500. You need not to worry about this. Okay, now see here. Here it's coming, the width is coming out to be 1000. Now you have to make it into two classes, break it into two classes, each of width 500 and 500. So what you will do here? So you will do here. So this will break into 2500 to 3000, and then it will break into 3000 into 3500. So what you have done here, you have broken the class interval with width 1000 into two classes, each of it 500. So 2500 to 3000, then 3000 to 3500. Accordingly, also you split this frequency. So 18. So you have split it into two classes. Therefore, you divide 18 by 2. So 18 divided by 2 is 9. So frequency of this will be 9 and this will be also 9. Okay, now this. See this. What is the width of this class interval? Width of this class interval is 1500. Okay, this is 1500. Now you have to break into classes such that each has width of 500. So you start with 3500 to 4000. Okay, then 4000 to 4500, then 4500 to 5000. So you have broken down this class into 3 subclasses, each of which 500. So accordingly, you will divide this by 3. So 12 divided by 3 is 4. So each will have a frequency of 4. Okay, similarly here 5000 to 7000, the width is 2000 here. You have to break it into subclasses of 500 each. How you will do it? So 5,000 to 5,500, then 5,500 to 6,000, then 6,500 to 7,000, then 7,500 to 8,000. So you have broken into 4 classes. So this frequency will be also divided by 4. Each will have the frequency as 2. So this is how you have to convert unequal class into unequal class interval width into equal class interval width. So this is what I was talking about. So we have broken each class with width which is 500. So the classes which do not have the width as 500, we have broken it into 500. Similarly, we can do for 7,000, 7,500 and 7,500 to 8,000. Okay, so this will be broken into 2 classes, subclasses 7,000 to 7,500 and 7,500 to 8,000. Then this 2 will be divided by 2. So frequency will be 2 divided by 2. That is 1 for each. Okay. So this is how you convert histogram with unequal class interval width into equal class. So this is with unequal class interval width. Okay. So if you see 1,000 to 1,500, it was 5. Okay. 1,000 to 1,500, it was 5. In the original, see here, 1,000 to 1,500, it was 5. Okay, this is 5. Now, and 1,500 to 2,000, it was 12. So 1,500, this is 1,500 to 2,000, it was 12. So this is for unequal class interval width. Okay, now, so this is what is histogram with unequal class interval. Okay. Now, next, which we will study is, we'll study the frequency polygon. So what is a frequency polygon? So a frequency polygon is basically a graphical presentation of the frequency distribution. Okay, as the bar diagram and histogram. A polygon is basically a many-sided closed figure. So it has many sides. So how is a frequency polygon constructed? A frequency polygon is constructed by taking the midpoint of the upper horizontal side of each rectangle. Okay, so it's constructed by taking the midpoint of upper horizontal side of each rectangle. Okay, on the histogram, and you have to connect, and then subsequently you have to connect these midpoints by straight lines. Okay, so if we draw a smooth curve over these points in such a way that the area included under the curve is approximately the same as that of polygon, then such a curve is known as frequency curve. So what is a frequency curve here? So if we draw a smooth curve, okay, so if we draw, this is the smooth curve which we have drawn by connecting the midpoints. Okay, so this curve is known as a frequency curve, and the area included under the curve is approximately the same as that of polygon. So basically, so what is the difference between a histogram and a frequency polygon? So histogram is usually associated with discrete data, and a frequency polygon is appropriate for continuous data. Okay, so this was about frequency polygon. Then let's study what do we mean by ogives or cumulative frequency curve. Okay, so what is an ogive? So ogive is basically graphical presentation of a cumulative frequency distribution. So it is a graphical representation of a cumulative frequency distribution. And when the graph of such distribution is drawn, it is called cumulative frequency curve or ogive. Okay, so there are 2 types of ogive, the less than ogive and the more than ogive. Okay, so first study what is a less than ogive. So what happens in a less than ogive? In this method, the upper limit of the various classes are taken on x-axis. So what happens here? Upper limit of various classes are taken on x-axis. Okay, and the frequencies obtained by the process of cumulating the preceding frequencies on y-axis. So what do? We form the cumulative frequency which we studied earlier, and then these cumulated frequencies, they are plotted on y-axis. Okay, so frequencies obtained by cumulating the frequencies are plotted on y-axis. So this is how a less than ogive is drawn. So by joining the points, so you'll plot the points, and by joining the points we get less than ogive. Okay, so let us consider this example. So here this is the daily sales in thousands. This was the earlier example, and these are the number of companies. Okay, so how do we draw the less than ogive here? So if you see here in this graph, so the first plot is of 2015. So here, so this, if you see, this is the first point, that is 20 and 15. So what is 20 here? What is 20 here? Upper limit. So 20 is the upper limit of the first class. So upper limit is taken on the x-axis. So upper limit is of the first class. Okay, then upper limit of the second class, upper limit of the third class, so 20, 30, 40, 50, and so on. Okay, so if you see here, we have taken the x-axis 20, 30, 40, 50, 60, 70, 80, 90. So these are plotted on the x-axis. Okay, on y-axis, what do we plot? So y-axis, we are plotting the frequencies. So here, if you see 15, so these are the cumulative frequencies. So these are the original frequencies, and these are the cumulative frequencies. Okay, so if you remember how this, the cumulative frequency of first will remain the same. Cumulative frequency of second will be 15 plus 22. Okay, adding these two, that is 37. And then how you will get 72? So that will be 15 plus 22 plus 35. Okay, so that will be 72. So similarly, we will calculate the cumulative frequencies. We'll plot these cumulative frequencies on the y-axis. So accumulating the frequencies, they are plotted on the y-axis. So as you can see here, these are the cumulative frequencies 15, 37, 72. They are plotted on the y-axis. Okay, so a point 20, 15 is 20 and 15 somewhere here. To 20 and 15, this is the point. 30 and 37. So this is the point 30, and here somewhere is 37. So this point is plotted. And when you join all these points, you get a less than ogive. Okay, is this clear? So this was about less than ogive. The second is the more than ogive. So what happens in a more than ogive or cumulative frequency curve? This can be drawn by taking the lower limits. So what happens in this? Lower limits are taken on the x-axis. Okay, so here you take lower limits. So lower limit of this class is 10, 20, 30, 40, 50, 60, 70, 80, and so on. Okay, and the cumulative frequencies on the y-axis. So accumulating the frequency, these are the cumulative frequencies. So these are taken on the y-axis. But here you have to see, so here how you are accumulating? You are accumulating more than 10. Okay, so more than 10 is means you have to add all of these, because all of these are more than 10. So this will be 15 plus 22 plus 35 plus 30 plus 25 plus 20 plus 16 plus 7. So this will equal to 170. Okay, more than 20 will be here onwards. Okay, so it will be 22 plus 35 plus 30 plus 25 plus 20 plus 16 plus 7. So that will be 155. More than 30 will be from here to here. So it will be 35 plus 30 plus 25 plus 20 plus 16 plus 7. Okay, and so on. More than 80 are just 7. So here it is 7. Okay, so you are plotting here the same things you are plotting here. Okay, so on the y-axis, what you are plotting? Again, you are plotting the cumulative frequencies, but more than type. Okay, so here you are plotting 15 and 170 you will plot here. Okay, so sorry, it will be not 15, it will be so on x axis the lower limit is there. Okay, the 10 and 170 you will plot on the graph. Okay, so here you're plotting 10 and 170, this 10 and 170, this point. Okay, the next point is you're plotting the lower limit, that is 20 and 155. So you are plotting 20 and 155. Okay, so you see this is 20 and 155 will be somewhere here. Okay, so this point will be 20 and 155. Okay, similarly, you will have to plot 30 and 133. Okay, so if you see here, this is 30.30 and 133. Similarly, you have to plot here 40 and 98. Okay, so you have plotted here 40 and 98. So similarly, you will plot all the points, and when you will draw a line connecting these points, then you will get a more than ogive. Okay, so you have to remember one thing. So in this more than ogive, you are taking more than 10, more than 20, means more than the lower limit, more than 10, more than 20, more than 30, more than 40, and accordingly you are finding the cumulative frequencies. Okay, and in less than ogive, what you are doing? Less than 20. So less than 20 is 15. Okay, less than 30. How much is less than 30? 15 plus 22 is less than 30, as we were doing. Less than 40, how much is less than 40? 15 plus 22 plus 35, that is 72. So this you have to remember. So in less than ogive, we take less than cumulative frequencies, and in more than ogive, we take more than cumulative frequencies. Okay, so this is how a less than and a more than ogives are drawn. Okay, so this was all about this unit. Okay, so so let us revise. So in this unit we studied what all we studied. First of all, we understood the study with the need and significance of the presentation of data. Why data presentation is necessary? Because it clarifies the data and you can understand the data better. Raw data will not give you any idea about what the data is telling you. Why is the need of classifying the data? Classifying the data is for clarity of the data. And what are the various types of classifications we studied? We studied bar diagrams, we studied histograms, okay, we studied frequency polygons and so on. Then we constructed a discrete frequency distribution for discrete data and continuous data. So discrete data, no fractional values were allowed, and continuous data, fractional as well as integer values are allowed. Then we studied how to present a frequency distribution in the form of bar diagram, histogram, frequency polygon, and ogives. So this was all about unit 2. So these are some of the questions which you need to answer and which you need to practice. So first is what you understand by classification of data. Then second, you have to illustrate the difference between qualitative and quantitative data with the help of suitable example. Third is you have to distinguish between discrete and continuous frequency distribution, class limits and class interval, inclusive and exclusive method. Okay, so this is a very basic chapter of classification and presenting the data. So please read it very carefully, and once you are able to understand all the terms, especially class limits, class interval, how to calculate midpoints, and how to convert inclusive classes into exclusive classes, all such things, if you are able to understand, then the further units will be quite easier to understand, and it will be much simplified for you. Okay, so all the best to all of you. Okay, I'll meet you in the next unit. Okay, bye-bye.